What are the light cones? Let's begin this with a graph, a very simple graph which we like many of us may have had in our schools. And here we are representing one of the axis as time axis and one of the axis as the space axis. I'm suppressing here the y and z axis here, as it may become more complicated for you guys to imagine. So I'm representing here x axis by t, which is time, and y axis by x, which is spatial axis somewhat. So basically time is in seconds, and this distance, or regarded as length, is in meters. Now what I'm gonna do here, I'm gonna plot a motion of a car, somewhat like a random graph like this, where, so let's say at this point, when you have a slope, when you calculate slope at this point, you get an instantaneous velocity of a car at that particular point, in time, and in like wherever it is in terms of distance. But let's do the same thing with a light. Like how would be the same graph when we plot it in terms in case of light. It just will like be this. Yeah, as compared, we are just comparing the motion of car, just be the graph of the motion of a car to the graph of the motion of a light. So this is the graph of the motion of light. Basically it's parallel to the y-axis, which we represented as x. So it's basically parallel to that. But let's say a coordinate system, we define some coordinate system such that, let's say we draw a new coordinate system over here, and in this new coordinate system, we what are doing is just that, wrapping this coordinate system, like we are just converging this coordinate system in a way, we are wrapping a paper, like for example, in such a way that this this graph, which is parallel to the y-axis, becomes 45-degree aligned the horizontal. Yeah, this is the same graph of light which we just discussed over here, which was parallel to the y-axis. Now we have wrapped up, we have transformed our coordinate system in such a way that it is now traveling at the 45 degrees graphically. Let's extend it to here. If you compare, like if you draw the same graph over here somewhere, in our changed coordinate system, it would somewhat like this. And when you travel at the speed of light, then your graph correspond to this 45-degree inclined line, which is a graph of these something which travels at the speed of light, which is a photon itself. This is basically a normal graph. So a light cone, let's draw it like this. Don't worry, I'm gonna explain you guys like what is the structure. This is the same graph of light which we have. So basically in this our new graph, in new coordinate system, basically light always travels at the 45-degree, and something as in our universe, there's a universal constant, like how fast anything can go is the maximum. There is a maximum speed limit in this universe, like anything can travel at. So this is your graph. So let's say we're traveling at this graph, and when we exceed the speed, we start to tend toward this, and when we tend toward this, you require like so much mass energy. I mean the infinite mass amount of mass and energy you get, when you get near to the speed of light, when you reach near to this graph, and you require infinite energy to push your cart, or pull your cart, whatever you call it as. So basically, uh, you require a lot of amount of energy, infinite energy, to make your graph, like this, like to to look like what it is here in 45-degree aligned to the horizontal. And this is what light cone is. So it's the basically, analysis of your graph, like when we have, our coordinate system, you know uh, being changed from here to here. And what is this 3D structure, this cone like structure? This cone like structure in real life, now this was a two-dimensional diagram. In real life we have all three dimensions, right? So this is was just what do you call, two-dimensional thing, like we just used one spatial here and one time over here. In real life we have, four dimensions, one dimension of time and three dimension of space. Now what you are considering is, we are not considering here time. Like, yes, we are considering here the time, and what you are considering is also the, the space. So it's not basically a four-dimensional diagram, but what you're considering is just, the what do you call it, the two dimensions in space and one dimension in time, and you have a 3D figure over here basically. So it's a combination of just two-dimensional space and one dimension of time, and we have this figure, like, yeah, which is what we call it as, a light cone.